For decades, Hawaii's volcanoes followed a predictable script: routine lava flows, careful warnings, nothing like the nightmare that just shattered scientific certainty. Overnight, a 1,200-foot pillar of molten rock exploded skyward from a vent that didn't even exist on official maps. An eruption so violent that experts are calling it a once-in-a-century shock to Hawaiian volcanology. No warning signs, no time to react. And the lava shot hotter and higher than anything Hawaii has recorded in living memory, raining liquid fire across a landscape the size of Manhattan. Scientists, scrambling for answers, now fear this awakening could signal seismic changes deep beneath the islands, raising a terrifying question. What if the rules that kept Hawaii safe no longer apply? Deep beneath the Pacific Ocean, a column of superheated rock rises from the Earth's mantle, punching through the moving crust above. This is the Hawaiian hotspot, a stationary plume that has been feeding the island's volcanoes for millions of years. Unlike most volcanoes that form at the edges of tectonic plates, Hawaii's volcanoes build up in the middle of the plate, carried northwest by the relentless drift of the Pacific Plate at about 3 inches per year. As the plate moves, new volcanoes emerge in a chain, each one born as the crust passes over the fixed hotspot. Mauna Loa, Kīlauea, and their extinct ancestors all owe their existence to this deep, persistent engine. The process is usually slow and steady. Magma from the plume melts its way upward, collecting in reservoirs beneath the surface. When enough pressure builds, it escapes through cracks and vents, producing the gentle lava flows that have shaped Hawaii's landscape and reputation. Scientists at the Hawaiian Volcano Observatory have relied on this dependable pattern for decades. The expectation is clear. Eruptions here tend to be predictable, with warning signs like swelling ground, increased gas emissions, and clusters of small earthquakes. These signals give experts time to monitor, model, and alert nearby communities. The hotspot's constancy has set the stage for a kind of volcanic routine, one that scientists trust and that residents have learned to live with. Even the largest eruptions, like those in 1959 or 2018, followed this script: a gradual buildup, clear signals, and eruptions that, while dramatic, rarely come without warning. This baseline of steady, well-understood behavior is what makes the recent explosive awakening so unsettling. When the rules are known, risk can be managed. But when the engine that drives Hawaii's volcanoes seems to skip a beat, even the most experienced observers are left searching for answers. On a November night in 1959, Kīlauea Crater became the site of a volcanic spectacle that left even seasoned geologists at a loss for words. A single vent, no wider than a city street, unleashed a jet of molten rock nearly 1,900 feet into the air, higher than any fountain ever recorded in Hawaii before or since. For 36 days, the eruption unfolded in pulses, each one building to a towering crescendo, then fading, only to surge again with renewed violence. The sound was compared to a freight train passing overhead, a roar that rattled windows in towns miles away. Molten droplets rained down across the forest, igniting fires and coating the landscape in a crust of black glass. Day after day, teams from the Hawaiian Volcano Observatory braved the heat and ash to measure, sample, and document every phase of the eruption. Their notebooks filled with sketches and numbers, but also with awe. One scientist, quoted in the official HVO report, called the event predictable yet astonishing. Every surge followed the patterns we'd modeled. Every tremor gave us warning. The volcano was powerful, but it played by the rules. That eruption became the gold standard for Hawaiian fountaining. Researchers built their models around it, using the 1,900-foot mark as the upper limit for what the island's volcanoes could achieve. The 1959 event's warning signs were textbook: swelling ground, rising gas, persistent tremors, and a steady climb in temperature. Each signal fit neatly into the sequence scientists had come to trust. The Kīlauea fountain proved that even the most violent eruptions could be forecast, monitored, and, at least in theory, managed. For decades, this record stood unchallenged, a reminder of both the beauty and the predictability of Hawaii's volcanic heart. But as the decades passed, the memory of that towering fountain faded into the background, a benchmark rather than a threat. No one expected the rules to change. At the edge of Halemaʻumaʻu Crater, a wall of fire rises into the darkness. A single, narrow vent blasting molten rock nearly 1,500 feet straight up, higher than the Empire State Building. The roar drowns out every other sound. Each pulse of the fountain hurls a storm of glowing droplets and Pele's hair, scattering glassy threads across the caldera. The ground shakes in rhythm with the eruption's heart, a deep, chest-thumping tremor that rattles field notebooks and camera tripods. Scientists from the Hawaiian Volcano Observatory, stationed only a few hundred yards from the vent, scramble to record measurements as the heat fogs their lenses and ash drifts sideways in the wind. One volcanologist, caught in the glare of the eruption, shouts into a radio, "Height estimate now at 1,500 feet. Repeat, 1,500. Lava pours out at a staggering rate, more than 500 cubic yards every second, filling the crater floor with a river of fire. In just a few hours, over 13 million cubic yards of new rock spread out, swallowing nearly 2/3 of the caldera's surface. The fountain's column glows orange and white, flickering with bursts of gas that launch molten jets even higher. Volcanologists scramble to adjust their models as the eruption defies every prediction. Instruments measure jet velocities near 95 meters per second, fast enough to launch a car down a highway in the blink of an eye. The temperature at the vent edges past 1,150 degrees Celsius, hotter than any steel furnace. Crowds gather at the national park overlook, their faces lit by the reflection of the fountain. Some cheer, others fall silent, stunned by the scale. Even the most experienced scientists admit to feeling small. One writes in a field log, "I've never seen anything like this, not even in 1959. The spectacle is both mesmerizing and terrifying, a reminder that beneath Hawaii's beauty lies a force capable of rewriting history in a single night. By midnight, the overlook roads were jammed with headlights, and the park's main lot overflowed onto the grass. Thousands pressed against the railings, phones raised, faces flickering orange in the volcanic glow. Some shouted in disbelief as each new pulse of the lava fountain soared higher, dwarfing every expectation. The roar of the eruption drowned out nervous chatter, but not the rising anxiety. Rangers struggled to keep the crowd back as ash drifted on the wind, stinging eyes and throats. Portable toilets ran out of water. Cell service collapsed under the strain of so many live streams and frantic messages home. In the chaos, scientists raced between their instruments and the command tent, radios crackling with urgent updates. An HVO field volcanologist, voice shaking, called in. "We're seeing sustained heights over 1,200 feet. This is beyond anything in our models. Fallout is unpredictable, requesting immediate clearance for personnel downwind." Body cam footage later revealed the tension, hands trembling as they logged numbers, sweat streaking through ash on their faces, a sense of disbelief at the scale of what was unfolding. One expert, caught off guard by a sudden surge, later wrote, "I felt the heat through my boots. Every instinct said to run, but I couldn't look away." Families from Volcano Village and nearby towns watched from truck beds and folding chairs, some weeping, others silent, all transfixed by the sight of Pele's fire reclaiming the land. For older residents, the eruption brought back memories of past evacuations, of hurried departures, sacred objects bundled into cars, and the ache of leaving ancestral ground behind. Tourists, drawn by the promise of a spectacle, found themselves gripped by fear as the ground trembled beneath their feet. "I've never felt so small," one whispered, eyes wide as the sky rained molten glass. As the hours dragged on, emergency teams debated how to move the swelling crowds to safety. The eruption's unpredictability forced a constant reevaluation of danger zones. Even the most seasoned scientists admitted they had no idea what would happen next. The only certainty was that the rules had changed, and everyone, experts and onlookers alike, was at the mercy of the volcano. At the Hawaiian Volcano Observatory, the routine hum of data streams suddenly faltered. Tilt meters, usually quick to register the swelling or shrinking of the caldera, showed barely a twitch, just under 1 microradian in the 24 hours before the eruption. Seismometers, spread across the summit and rift zones, logged only mild tremor. No clusters of earthquakes, no signature bursts that would hint at magma on the move. Gas sensors, positioned to catch every whiff of sulfur dioxide, reported background levels holding steady at around 1,300 tons per day, numbers that, in past eruptions, would have signaled business as usual. The command center's dashboards, built to flag the slightest anomaly, stayed stubbornly green. Even satellite feeds, delayed by hours but trusted for broad deformation, failed to show the swelling or slumping that typically precedes a major outburst. The Uekahuna tilt meter, perched above the crater, recorded a total inflation of just 22.3 microradians since the last episode, far short of the spikes that used to trigger eruption warnings. For days, the system looked quiet, almost sleepy. Then, without warning, the ground split open. Lava roared skyward, and every instrument on the rim registered the shock. By the time alarms blared, the fountain had already punched through the darkness, lighting up the caldera. Field volcanologists scrambled to cross-check the logs, searching for any missed clue. One analyst, reviewing the timeline, muttered into the radio, "It's not that the data was silent, it's that nothing pointed to this. Every tool we had said wait, then the volcano jumped ahead." In the aftermath, experts pored over the numbers, replaying each blip and baseline. The absence of warning signs became the warning itself. As one senior HVO scientist put it in a press briefing, "We're trained to trust the instruments, but this eruption slipped past every threshold we set. It's as if the volcano refused to announce itself until it was too late." Inside the Hawaiian Volcano Observatory, the focus turned from the chaos at the crater rim to the puzzle beneath it. The eruption's suddenness had left monitoring teams stunned, but the physical evidence pouring from the vent offered new clues. High-speed cameras and radar tracked the fountain's ascent. Molten rock blasted skyward at nearly 95 meters per second, carrying a gas load that made up almost a third of the erupting mixture. That gas content, 20 to 30% by volume, was among the highest ever measured at Kīlauea. The vent itself, no wider than a 2-lane road, acted like a pressure valve thrown wide open. Its steep cylindrical shape focused the force of expanding gas, channeling the eruption into a single towering jet. A volcanology modeler, reviewing the numbers, pointed out a troubling pattern. The eruption's violence was not just about the volume of magma, but how efficiently the vent converted gas pressure into vertical thrust. The narrow geometry and sudden decompression allowed gas bubbles to expand explosively, fragmenting the magma into droplets and filaments, Pele's hair, before hurling them hundreds of meters above the crater floor. The physics matched ballistic calculations almost perfectly. To reach heights of 1,200 feet, the lava had to leave the vent at speeds exceeding 340 kilometers per hour. Yet, the real mystery lay deeper. Despite a web of seismic sensors and satellites, there was no sign of migrating earthquakes or ground deformation that would normally betray rising magma. INSAR analysis, often used to spot even millimeter-scale swelling, showed no swarms or surface shifts before the eruption. The only seismic hint was a faint linear trend of minor tremor right before the vent opened, a detail so subtle it was nearly lost in the background noise. The modeler, paraphrased for clarity, warned colleagues, "It's as if the volcano reorganized its plumbing overnight. The old rules didn't apply. We're seeing a system capable of channeling vast gas-charged magma straight to the surface without the usual warning signs." This episode forced a reckoning. If Kilauea's internal pathways could change so rapidly and quietly, future eruptions might arrive with even less notice. The technical mystery was complete, but the stakes had never been higher. Scientists were left to wonder, what else was happening beneath the crater, unseen, unmeasured, and possibly just beginning? Scrutiny fell fast and hard on the agencies tasked with watching Hawaii's volcanoes. In the weeks after the eruption, civil defense planners faced tough questions about why the fountain's warning signs slipped through the cracks. Congressional hearings zeroed in on a simple, uncomfortable truth. From 2019 to 2022, the Hawaiian Volcano Observatory lost ground. Budgets had stayed flat or shrunk, even as the need for constant, high-tech monitoring grew. By 2022, nearly a quarter of the summit's gas sensors and almost 1 in 5 seismic instruments were offline, waiting for repairs that never came. Staffing was stretched thin. 5 to 8 key positions went unfilled, leaving scientists to patch together coverage with overtime and borrowed hands. Policy reviews revealed that temporary disaster funds after the 2018 eruption had plugged some holes, but the core budget never caught up. Civil defense drills were scaled back, and early warning programs lost almost a quarter of their funding. When the 2025 eruption hit, 4 seismic nodes and 6 gas sensors near the vent were dark. Officials defended their teams, pointing to the world-class tools still in place, but the gaps were real. The aftermath brought a flood of blame, but also urgent calls for stable, long-term funding, an acknowledgement that in the face of unpredictable fury, half measures aren't enough. As the last embers of the eruption faded, a different kind of silence settled over the summit. At Wekahuna, Uekahuna, high above the caldera, small groups gathered in the pre-dawn dark. Some brought lei or tea leaves, placing them gently on the earth as offerings. Others stood in quiet prayer, whispering words of gratitude and caution to Pele, the living force behind the volcano. For many native Hawaiians, this was not just a spectacle or disaster, it was genealogy unfolding, a reminder that the land and its people are bound by ancient ties. A respected practitioner, standing near the overlook, spoke softly to those around her. "We do not control Pele, nor do we fear her. We respect her power and live in her domain." No sirens, no speeches, just the steady rhythm of oli chants drifting on the wind, hands reaching out to touch the stones, and children watching as elders traced patterns in the ash. The summit itself remained restless, with tilt meters showing slow inflation, hinting that the volcano's story was not finished. In the face of uncertainty, the community turned to tradition, seeking balance between awe and humility. The warning was clear. Respect the land, listen to its rhythms, and remember that in Hawaii, every eruption is both an ending and a beginning. On October 17, 2025, Kīlauea's south vent unleashed a lava fountain reaching 1,500 feet, surpassing any eruption seen here in decades. This event shattered expectations built on over a century of monitoring, including the benchmark 1,900-foot Kīlauea Iki fountain of 1959. Unlike past eruptions, this awakening arrived without clear seismic signals, tilt changes, or gas emissions, leaving scientists and emergency officials unprepared. Instrument records and INSAR data confirm the absence of typical warning signs, while post-eruption surveys show ongoing summit inflation. Despite advanced monitoring and decades of research, the cause of this silent buildup remains unsolved. Federal and state budget cuts from 2019 to 2022 left critical gaps in the system, a fact now under review by civil defense authorities. Indigenous practitioners have responded with renewed ceremony, urging respect for Pele's unpredictable power. As the summit continues to swell, one fact remains: Hawaii's volcanoes can still outpace the tools designed to understand them, and the next chapter is unwritten. Yellowstone's 100-foot crack finally reveals what's beneath, and what it showed has scientists flat out stunned. Imagine the Earth splitting open in the heart of America's supervolcano, pulling back the crust to reveal glowing streaks, strange heat pulses, and minerals that shouldn't exist at the surface, or anywhere near it. For decades, experts believed they'd mapped every layer of Yellowstone, from its towering caldera to magma chambers miles below. But this time, the readings are breaking all the rules. Geological signatures point deeper than anyone's ever drilled, and pockets of gas defy known science. Everyone's asking, is this just a strange surface wound, or have we unsealed a hidden engine of the continent? The answer could change everything you thought you knew about Yellowstone's true power. Yellowstone is not just a park, it's a scar left by one of the largest volcanic systems on Earth. The caldera, a vast sunken basin, stretches 40 miles long and 25 miles wide across the heart of the Rockies. That's bigger than the city of Los Angeles, and nearly as deep as some of the tallest skyscrapers are high. Every inch of this landscape is built on a history of violence. Over the past 2.1 million years, the supervolcano beneath Yellowstone has erupted 3 times with unimaginable force. The first blast, about 2.1 million years ago, ejected enough ash and rock to blanket half of North America. The second, 1.3 million years ago, tore open a new crater. The third, only 640,000 years ago, created the modern caldera, leaving behind a depression so wide that standing on one rim, you can't even see the other side.